During this lesson, what we are going to do is to see the different classifications that we can make of the wave motion according to a particular characteristic. What we are going to do is a first subsection in 4 types of classifications of wave motion according to the first one, according to the medium of propagation, according to whether it is a material medium or a non-material medium. The second type of classification according to the direction of propagation of the perturbation with respect to the direction of vibration of the characteristic we are analyzing. The third, according to the confinement in space of the perturbation, and the fourth, according to the dimensions of the propagation that occupies the wave motion. We could make more classifications, but for that I must first introduce new concepts and new definitions. Starting with the first type, depending on the medium of propagation of the wave motion, we divide between material waves and non-material waves. As its name indicates, the material waves are those that need a material medium to propagate, and examples of them are the waves that are produced on the surface of a fluid, the waves that we can produce by beating on a rope, the waves that we can produce in springs, as in the spring, for example, that I can produce a wave motion in this spring that I have brought, thermal waves, waves that are produced in the strings of stringed musical instruments, etc. And as non-material waves, logically, they are those, as their name indicates, that can propagate in a vacuum. Within the non-material waves, we have those widely known by us, such as electromagnetic waves, that would cover the entire electromagnetic spectrum, but also gravitational waves, probability waves. An example of electromagnetic waves is represented by this visible spectrum that we have in this case, but it is not the only thing we have in the electromagnetic spectrum. Then I will comment a little bit more, and in a little bit of peculiarity, here I would have a representation in this movie of what would be the composition of an electromagnetic wave that is given by a superposition of electric and magnetic fields, for example, as in this case, electric fields. Vibration, or represented its vibration by the red vectors, and magnetic fields represented its vibration by the green vectors. Of the electromagnetic spectrum, as I said before, the visible spectrum that we are able to detect with our eyes is a small part, but the electromagnetic spectrum covers much more, from the radio waves that I have represented here to the gamma rays that cover different components of the study that we have, of the knowledge that we know. Another type of classification can be made according to the direction of propagation and the direction of vibration of the characteristic that we are studying, the wave motion. I mean, we will find transverse waves when the propagation of the disturbance is in one direction. For example, in this case, the waves produced on the surface of the fluid, the direction of propagation would be in this direction, but the particles of the medium, what they do is to vibrate in a direction perpendicular to that propagation. The energy that is transported by the wave motion is in one direction, and the particles of the medium vibrate in a transverse direction. In the case of electromagnetic waves, we would have another example of this type of transverse waves. The waves produced in the strings of the viola, in this case, would also be an example of transverse waves. However, the sound that will reach our ears produced by this musical instrument would be a type of longitudinal wave. Sound propagates through pressure waves that are moving away from the sound source through space, and in that case we would have waves where the vibration of the particles, if it is sound, the air particles vibrate in the same direction as the propagation of the energy carried by the sound wave. The waves produced by the sonar in submarines would also be an example of longitudinal waves. The sound waves produced by this clarinet also, or also the waves that I can make with this spring. We are going to see a little bit enlarged the waves that I can make with this spring if we look at it. Now with this screen enlarged, I can make or generate sound waves if the waves, transverse waves, if you expire them in this spring, we see a movement. Their movement is transverse with respect to the propagation of the wave that I am generating. Longitudinal movement, longitudinal waves. I can generate only one pulse, or I can originate different beats. And we see that the movement of the expiras and of the direction of propagation of the wave motion of the perturbation is the same. And in the transversal, Both movements would be perpendicular. Very well. But I can also produce waves that are defined as mixed waves, which is a combination of the two previous transverse and longitudinal. For that, I want to take advantage of the following. Representation where I can select here. What I'm going to do is select two particles from the medium to track their motion. And if we remember, as we were looking at it in the first of the lessons, the motion of each particle in the medium, in this case, I would have a transverse wave. I can change it to a longitudinal wave type. And in this case, we would have the same direction of motion or a combination of both, and we would be talking about a mixed wave. An example of these mixed waves, we have it in the waves that are produced on the surface of the sea. It is a combination of transverse waves and longitudinal waves. Continuing with the classifications we are making, it turns out that now, according to the confinement in space of our wave motion, we will distinguish between traveling waves and standing waves. Traveling waves are those that from the emitting focus of the wave propagate freely throughout space. They would be from the perturbation of the surface of a fluid. These waves propagate throughout the surface of the fluid. The sound waves from the emitting focus, in this case Amanda who is speaking or myself speaking and explaining this lesson, propagate throughout space as long as it is not limited by different obstacles. You could have light emitted by a laser, light reaching deep into a forest from the sun, and standing waves are a type of waves that are confined to a certain area of space. Standing waves. We would have them, for example, in this case, if Amanda is producing beats that are going to reach J and are going to be confined in this zone of the string, or as in this case, the standing waves produced in the strings of the viola. The standing waves, as we can see in this animation, actually arise from a superposition of a generated wave and an interference with a standing wave. In this case, we have a wave that travels in a clockwise direction, the red one, and a wave in a counterclockwise direction, the green one. If we look at the resulting standing wave is represented by this blue profile where I can fix the point where the maximum and minimum always occur. It is not a wave that moves, it is not a traveling wave, it is a wave whose maximum and minimum always occur at the same points in space. Here we have a very clear example, and according to the dimensions that the wave motion occupies in its propagation, we are going to distinguish between dimensional waves when the perturbation is only propagating in one dimension of space, as we would have in this case, or also as I have shown previously in one of the animations that we can give. Here I have only in this dimension that the propagation or the propagation of the energy of this wave motion is taking place. Two-dimensional waves, when what I have is that the perturbation is propagating in two dimensions of space, as for example on the surface of this fluid due to the impact of the droplets, or when we are perturbing the membrane of this drum hitting it, or three-dimensional waves, as are the sound waves as the waves emitted by the sonar, or the waves emitted when speaking, or also the seismic waves produced, as during from the epicenter in an earthquake would also be three-dimensional waves. Well, with this we have seen some of the different classifications that we can find of wave motion, and we see that what happens is that the differentiation is because it takes into account different aspects of geometry, nature, disturbance, environment, and so on. Later on I will mention other types of classifications, but for that I need to introduce new definitions. We will continue in the next lesson. Thank you.